Hello everyone and welcome to the stream. Hope everybody is doing well tonight. We're going to be doing something a little bit different tonight than what we've done up till recently. We are actually going to be taking apart one of our systems tonight. It's something I thought that I could put off, but when we got started on the renderer, I'm sorry, not the renderer, the editor last week, it kind of brought me to the realization that we need to actually start something now. And that something is the render graph. So that's what we're going to be getting into tonight. With that said, I've got a couple things I want to try and stream, a couple new things in terms of presentation. So we're going to give those a shot and see how they go and see if they work or not, and go from there. But before we jump into any of that, I do want to go ahead and take a quick second to thank all of the supporters of the channel. So that is starting with our partners, who are the highest tier of support on Patreon as well as YouTube memberships. They are Arslia, Gerboles Inc., Patrick Kuhlman, and Wen Sheng. I'd also like to thank all of our other supporters. Everybody else listed here on the screen is the other tiers of Patreon, YouTube memberships, and of course our Twitch subscribers. So thank you all very much for your support. And of course, none of this would be possible without all of you viewers here. So thank you guys very much for your support and following along with the project. I greatly appreciate it. Coffee Lava, hello, welcome. How are you? Weird Trash Can, hello. I wish I could watch all the streams, but unfortunately I have to sleep. Yeah, I get it. This time doesn't work for everybody, unfortunately, but I do have to work a full-time job, so unfortunately this is the only time I'm available to do it right now. I'm hoping at some point I'll be able to do like more weekend streams or something like that, but it's not in the cards anytime soon. Okay, so as I mentioned, we started setting up our editor project last week and scaffolding that, and we kind of got to the views section and I sort of stopped. And it really got me thinking that our current view system really needed some attention, right? There's lots of things in there that we're either A, not using, or B, are kind of rigid in structure and whatnot. And so it kind of got me thinking about something I've been wanting to put in the engine anyways for quite a while, to make it a little bit more configurable, a little bit more robust and flexible. And that is a render graph. And so the render graph is something we're going to discuss tonight, and then we're going to start the implementation tonight as well. And the render graph is basically going to allow us to configure all of our render passes and things like that, as well as resources, and sort of the timeline that all those things happen, right? And we're going to start off with a code implementation of it, and then we are going to eventually add some sort of file format to go along with it, maybe JSON or something like that. I haven't decided yet. But what we're going to do tonight is basically discuss what a render graph is and how we are going to implement it here. It's going to be several different steps of implementation. So we're going to get a basic render graph up and running first. And then once we have that, we'll enhance it as we need features, right? So the render graph is basically going to replace the view system we have now. And the view system that we have now is this guy. And so basically we had this system where we had a view that was basically responsible for gathering up all of the data that was going to be needed to perform a render, generating what we call a render packet, and then firing that off to the renderer, which would then fire it back to the view to actually perform the rendering. And while in concept this was, I thought at the time, a kind of a good idea, it's kind of weird how it goes back and forth, right? And it's also tightly coupling the process of gathering all of our data as well as the rendering. And I think those two things should really be split apart. And it kind of will allow us to split things up a little bit better so that we can maybe kick off more than one update process at a time on multiple threads, and then sort of gather all that information back and fire it off all to the render graph all at once. So How many allocators are there on the engine right now? I just finished the linear allocator video. So we actually have, I'll show you here. So we have, whoops, that's the editor. Under memory right now, we have the dynamic allocator and the linear allocator. So the dynamic allocator basically is like a replacement for malloc. It's basically like a huge arena allocator, if you want to think of it that way. And so that's sort of what we use. We've piped in that as a replacement for malloc, right? So we can manage all of that. So we have that, and then we have a linear allocator. We probably are going to be implementing some other types, but these are the only two that we need right now. The linear allocator is basically used for our system startup, right? Because we don't really need to free memory on that once our systems are up and running. So all of our systems and our systems manager uses a linear allocator, as well as our per frame allocator is also using a linear allocator. So we're still very much using that for the time being. We'll probably do a couple of other things, like maybe a stat allocator and maybe a pool allocator as well at some point. You've already did a arena allocator, but never really got to use it. Yeah, so the dynamic allocator here is tied in with a free list that we manage, and we basically, like I said, it's basically just a replacement for malloc. So if you're at the linear allocator section, I think the dynamic allocator comes soon after that. We actually wind up touching it a couple of times throughout the series. So, all right. So I'm going to try something. And I haven't actually tried this on stream yet, so I don't know how it's going to work. But I basically have a tablet here that I'm going to try and use to draw things on. And we'll see how that works. Unfortunately, the battery is like almost dead, so I'm going to have to be kind of quick with this. But let's see. Let me go ahead and switch. I think it was this one. Yeah, there we go. Cool. All right. So what we're going to do is we're basically going to talk about what a render graph is and how we're going to set up a render graph, right? So a render graph essentially allows us to configure multiple render passes within a scene. It basically allows us to configure what happens in a single frame. And it's a little bit more complicated than that. It'll be a little bit more complicated than that once we actually start fully utilizing it in our applications, but our initial incarnation of it is going to be somewhat simplistic. So what we basically have is we have resources, which I'll put up here. Actually, you know what? I'll outline this whole thing. So let's just say we've got this whole thing here, which we're going to call our frame, right? And what we have is resources, which we're going to put up here. So actually, I'll write this in black and then outline it in a different color. So we have our our color, which is also our frame buffer, right? And that's the image that we essentially are drawing everything to, right? So we have a frame buffer here that we're going to call a resource, right? And then we also have our depth buffer, right? And that is, of course, an image resource as well, right? So we have these sort of global resources that we have. And then we have a collection of render passes. So right now we have a skybox pass, and then we have a world pass, which we are actually going to rename to scene, right? Because we are working with scenes or simple scenes, right? So we're going to rename that to scene. We also have an editor pass, which is used for drawing our gizmo and things like that. And then we have a UI pass, right? And we also have this sort of temporary wireframe pass, right? So I'll just put wireframe. Okay. And so these are our render passes, right? So I'll outline our render passes in red. And so this is what we essentially need to configure. I'm actually going to get rid of the wireframe one for right now. We'll implement it, but for the sake of keeping this simple, I'm going to eliminate that one for right now. So we have each of these things, and we basically want to work in a top to bottom order here, right? And so what we have is we basically have these two resources here that we want to run through these render passes. And then we essentially want to wind up at the bottom, which I will put in a separate color, where we basically want to write out, right? And this is basically going to end the frame, right? And so we're going to call this our back buffer, right? Back buffer. Now I know we're triple buffering, so technically it's not just a back buffer, right? It's one of many buffers that we're technically using, but for the sake of simplicity, let's call it the back buffer, right? LSR, hello, welcome. How are you? So basically what we're going to wind up with is we are going to have two types of ways of flowing this data from through these individual render passes all the way down here to our back buffer. We're going to have over here, I guess I'll just draw like a legend over here. We're going to have, actually, you know what, let me do the other one first. So we're going to have, let's go purple on this one. So we're going to have something that we're going to call sources, which is going to be represented by this, right? So that's a source. And this is basically going to be either a resource or an output from a render pass. You can think of it as, and you'll see how this makes sense here in a second. And then we're also going to have a second, what we're going to call a sink, right? So we have sources and sinks, and sources fit into sinks. That's why we're kind of using these shapes here, right? So the circle fits sort of into the socket there. So you can think of a sink as sort of a socket that takes a source, right? It takes a single source, and that's basically how it works, right? And so we're going to use sources and sinks to connect the dots along this, okay? So essentially what we're going to wind up with is we have this resource up here, which is the color for the frame buffer, right? And so this guy, we're going to hook up a source to be able to use, right? And the same is going to be true with the depth buffer, right? It's going to have a source associated with it, right? And these are globally accessible, so we'll make sure that our render graph has the ability to add global resources. And we're going to have a series of sinks on our render passes, right? So the skybox, if you recall, when we set that up, that just has a single input, which is the color, right? So in this case, the source for the color buffer goes into that, right? So we're going to call this guy, we're going to call him, let's see, what do I want to call this? I guess let's call this, we'll call this source the back buffer. And I'm just going to abbreviate this to back buffer, or BB, right? So the source we're going to call back buffer, and we're also going to call the sink back buffer, right? So you can have a source and a sink that are named the same thing, but you can't have two sources or two sinks that are named the same thing for a single render pass, right? So we have a sink that is called BB that is going to, or back buffer, that is going to take a source called back buffer, right? The next pass which is the world, which we're going to rename scene, is actually going to take two things. So it is going to take two sinks, right? And it is going to take the output of the skybox, which is going to be a source, right? And that's going to be the color, right? So that's going to be, again, the back buffer slash color. Sorry, it's kind of tight over here, right? And then the other thing that's going to take is it's going to take the depth buffer source, right? So we're going to call this guy, I guess, dB, right? And this is going to be dB, right? And so this guy now has two sources and two sinks, right? And then from there, it's going to output two sources, right? So we have our back buffer over here and our depth buffer over here, right? Because this pass writes to the depth buffer as well, right? And our editor pass is going to be another one that has two sinks, right? And then, just like before, we fit those sources into the sinks. And then the editor pass outputs two sources, right? Because it also writes to the depth buffer, right? So this is back buffer, this is depth buffer, right? Sorry about my terrible handwriting here. And the UI isn't going to care about the depth buffer, but it does take the back buffer, right? So we plug that in, and then it outputs the back buffer, right? And then this plugs in, oops, wrong color. This then plugs in to our global back buffer sink, right? So this guy down here is a global sink. And this is essentially the way that this whole thing is going to work. So essentially what we're going to wind up building is something like this. And the idea is that we eventually are going to have the ability to generate multiple render passes, potentially on different threads, right? Where we might have a couple over here, right? That maybe output something else, and maybe they also own their own resource, right? So they don't use any global resource, but maybe that render pass owns its own resource. An example of this would be our pick pass, right? And so we could, very easily plug that in somewhere along here as well, or just execute it and never actually plug it in at all, right? And it's just sort of its own freestanding thing. And so this is going to provide us the ability to be able to do this kind of stuff, right? And eventually, the way that it's going to work is, like I said, we'll be able to multi-thread some of this stuff, especially when we have a really complex render graph, right? Like I said, I did leave the wireframe pass out of this because it's just sort of a lot like, these guys here, right? It's kind of the same thing. So that is basically the concept of what we're going to go with. So we're going to start off, like I said, with a very simple design, and we're going to iterate on that sort of as we go. So with all that said, let me switch back to the right camera here. And I'm going to plug this tablet back in before it dies. Just give me a second here. I think it's got like 3% battery or something. I forgot to charge it earlier today. So anyways, that is basically the structure that we're going to go with, okay? And like I said, it's going to partially replace our view system. But when I say it's going to replace our view system, we're actually going to be able to use a lot of the things that our view system already provides. So we're actually going to be able to pick up a lot of that code and drop it in to our render graph. Let's see. Kohi, I tried learning Vulkan, and after 12 plus hours, I got a black screen. Did you get a black screen because you were clearing to black, or did you get a black screen for a different reason? I'm assuming because of the POG. I'm assuming the black screen was on purpose. You were clearing it red, but you still got black. Yeah, that's why I was asking. Yeah, I know the feeling, believe me. Having implemented GL from scratch, God, dozens of times at this point, I'm all too familiar with the black screen. And Vulkan is just as bad with that. So that's always fun. Probably going to have to crank up RenderDoc. All right. So, let's get started. I do actually, now that I think about it, though, there is a minor thing that I actually want to tweak before we get too heavy into this. There's something I've been meaning to do for a while. It's actually on the backlog, and I actually want to. Let me think. I want to open up. Well, actually, you know what? I want to look at frame data real quick because I realized there was a bug in here. Let's fix that first. So I have our frame allocator interface here that we added, I don't know, a stream or two ago. And we put the size in here, but we didn't actually add the block. So it should be, void pointer block. Which means engine .c needs to be updated as well. And I didn't catch this because it was a no-op, right? Because we're essentially not doing that with our frame allocator, but we still need to actually handle that. And the reason that came up is because I want to modify our D array a little bit. Because one of our to-do items in our backlog was to actually allow our D array to use one of our allocators, specifically the frame allocator. And so we want the ability to be able to use that instead of, essentially using our malloc. And the reason we want that is because we might want per frame D arrays that need to be stood up, and we don't necessarily want to have to destroy them on every single frame, right? It makes sense to just be able to use a linear allocator that gets wiped out anyways at the end of a frame, so that we don't have to go through those extra steps, right? So we're going to go ahead and modify D-array a little bit to kind of accept that, right? So the first thing I'm going to do is I'm actually going to bump this version up because it's going to be kind of an interface breaking change in some cases. So I'm going to bump that to 2, and then let's see, what's today? Today is the 30th, right? So we're going to go with 830, right? Oh, that should be 23. So what we're going to do is we're actually going to, we're going to get rid of this because we're not going to use that internally anymore. And we are instead going to replace that with a struct to make it a little bit easier to understand on the code side of it. But we're also going to forward declare struct frame allocator int. We do not want that, right? And the reason for that is because we are optionally going to take in a frame allocator. So the way that I'm planning on handling that is our internal quote-unquote D-array create is going to take a third parameter, which is going to be struct frame allocator int. And we're just going to call that, what do I want to call that? I guess we can call it frame allocator. Right? And if we're just using sort of the existing interface that we have now, that's just going to be 0 and it's not going to be used. But otherwise, we're going to go ahead and use that. The other thing that I want to do is I actually want to, some of these things are actually macros that don't really need to be, so I want to kind of clean some of those up too. And so that means that I can actually get rid of some of these guys. So destroy Field get and field set. We're not going to have fields anymore. We're going to replace that with something a little bit better. So we can get rid of those. We're going to get rid of pop and pop at because those aren't going to be internal anymore. We're basically just going to make those external. And then what we're going to do is we have darray create that was calling the sort of internal one with a size of the type. And here we're just going to extend this to also use a 0, right? And so that one works as expected. But what we're also going to do is we're going to copy that, right? And modify it a little bit. Whoops, not there, there. To take type and an allocator, right? And we'll just pass allocator here. And then allocator, a pointer to a frame allocator, right? Let's see, what did I... Oh, and then obviously we can't have the macro be called the same thing. So we're going to call this with allocator, right? So we have create, that's that way, and then also reserve internally calls create. So we're going to have to change this to pass a 0 here. And then we're also going to expand this to also take an allocator, right? In fact, I'm just going to paste that, and then we're going to say with allocator and allocator. Okay. So now we have sort of a second way to create these where we can specify a frame allocator along with it. Not sure if it's just me, but you are really quiet. Am I really quiet? Let me try and raise my mic up a little bit. How's that? Is that better? Let me know if it's if that's better or not. Hopefully it is. Okay, so we have that. And let's see. So we have this destroy here. We're going to get rid of that, change that to K API, and we're just going to have darray destroy. And that's basically just going to be a declaration at this point, right? Whoops, I forgot the void, right? And then the array is also going to take a void pointer, right? I think that's all we should need for that. Darray push is going to have to stay the same right now because we still need this. I'd like to deprecate that at some point to get rid of this sort of type of business that we're doing because we don't really need it, but that's going to be a widespread change across the code base when I do that. So I kind of want to do that on its own. So I'm going to leave that for now. Looks like we have ads starting here in just a second. So I'm actually going to pause for just a second so that you guys don't actually miss anything. So we will be right back. We got about a minute left on ads. About 30 seconds left, a little less. All right, and we are back. So Weird Trash Can asks, what's the downside of storing the states on the stack? So the answer to that is quite simply the size, right? You're very, very limited in how much stack space you actually have. And so most programs, particularly games, occupy gigabytes worth of memory, right? And you just don't have anywhere near that on the stack, right? You have megabytes on the stack. And so you just physically can't. It's not like there's even a downside to doing it. You just physically can't, right? That's really it, right? Like, it's not even really like an upside downside, like you can or can't. Like you just can't for something like this. You have to store it on the heap because that's the only place you have enough memory to do it. I hope that makes sense. Okay, so D-Ray push has to stay like that. D-Ray pop. Does this return anything? I don't think it does. No, because we have we have a void pointer, a value pointer rather. So we just need to add types here. And okay. Whoops. Okay. So that's our D-array pop. Our insert at also makes use of that type of stuff, so I can't touch that for now. The pop at, we're going to export that. That is also a return type of void. I think most of these things are, that aren't getters anyway. So this, of course, is going to be a void pointer. U64 for the index, and then a void pointer for the value pointer. And then we can get rid of that. D-Ray clear was calling a field set. We don't have field set anymore. We're not going to here in a second. So we want KAPI void, right? And array is a void pointer. Whoops. There we go. So we have D-array capacity, length, and stride. So these were just calling this D-array field get, which we no longer have. So this is going to be KPI U64, right? And then of course, right? It's going to be basically the same set of changes here. So it's going to be KPI void, a void pointer, and then delete that, delete that. KPI. Oops, these are U64. Sorry, these should be U64. U64. This is going to be void pointer. Right. So we have that, and then we also have this length set, which is using the darray field set. We don't have that anymore. So, wow. My highlighter just totally took a poop. But why though? Let me just relaunch. Oh. Let me just relaunch. Wow, that's really taking a poop. Okay. What is going on with my highlighter? Stack Overflow. That's awesome. You must really not like something I have in this file. This is going to be void. Void pointer array. Void pointer value. Whoops, that's U64 value. Okay. All right. So this is what our interface looks like now. We have mostly functions that actually utilize types, which is good. Yeah, it's not highlighting these things correctly at all. I don't know why. I'm not sure why it's complaining so much about this. That all looks correct. Who knows? I guess I'll find out when I go to build it. I might have a typo in there somewhere. Doesn't look like it though. Okay. Anyway, I'm gonna move on. So that's the change to the interface, right? So I'm gonna go ahead and make all the changes to the implementation. The way that we're going to do this is we are going to type def a new structure that we're going to call darray header. It's probably the way we should have done it initially. Darray header. Right. This is going to include our U64 capacity, our U64 length, and our U64 stride. It's also going to include frame allocator int allocator. Whoops, just allocator. Right? And then whether or not this allocator is set is whether or not it actually uses that thing. So that means we're going to have to include core, include core frame data is where that interface is defined. And then we have darray create. So this takes frame allocator int, which is short for interface. We'll take this as allocator, right? And we're no longer going to use this darray field length or any of this stuff, right? Because we're not storing it as an array anymore. We're storing it as a flat structure, which makes some of this math a little bit easier as well. So instead of header size being this, we're going to change that to size of darray header, right? And then array size, we'll keep that as the same. And then the new array is actually going to be conditional. So we're going to start this off being 0. And then we'll say if allocator, right? So if we have an allocator, then we're going to do one thing. Otherwise, we'll fall back to the default logic, right? which would be new array equals this, right? So if we have an allocator, we're going to say new array equals allocator allocate. Why am I not getting... okay, so in this case, we're going to say header size plus array size. Right? So if we have an allocator, we're going to go ahead and use that. Why is this bleating? Expected semicolon after top level declarator. Okay. Where are we missing a semicolon? Is that in the header file somewhere? Maybe we're missing one here. I don't see one missing here. We have that. You need to reopen this? No. Is there something in defines that got messed up? Don't think we've edited this file in forever. I'm not sure what would be missing. Yeah. I don't see anything wrong with it. All right, I'm just going to move on for now. I'm not sure what is going on. I've obviously mistyped something somewhere. So after we do our check here to make sure that we actually have, we've set our memory, we double check the length, which actually probably should be happening sooner. But after we do that, we are actually going to get rid of these. And we'll say darray header. I'm just going to say header. And we're going to basically cold cast the new array, right? Because we're still keeping the same memory layout where the we basically have the header first and then the actual array data after that. And what we return here is the actual data after that. So now we can say header dot capacity is going to be equal to length. Header length, confusingly, is going to be 0, right? Because we don't have anything there. And then header stride is going to equal stride. And then header allocator equals allocator, right? And then the only thing we'll have to do here is change up our math a little bit, right? So we're going to do a cold cast here to a U8 array, right? So that we, our math here basically moves us around 1 byte at a time. And then instead of field length, we're going to say header size, right? I really don't understand why this is messing up so badly. Oh, I might need to move. I can't picture that being it. Tried building debug. Too many arguments provided to function like macro invocation. Darray create. Oh. I got rid of the underscore. That's why. I have to hold on to that. That's what it is. Okay. All right. Incompatible pointer. Oh, right. This probably needs to be a void pointer. Okay. So that makes sense. Our DArray destroy is going to be pretty similar. I think, though... we have header is going to be... we're going to change this to actually DArray header. And then this is going to be... we're actually going to need header size first. So we'll say change header size is size of DArray header. And then this is going to be a U8 array minus header size. And that will be cold cast to DArray header. Right. Total size will just be header size plus header capacity times header stride. Okay, so we've got that. Expected expression. Oh. Okay. So that's destroy. Field get and set, we're not doing this anymore, so those can go bye-bye. DArray resize. So this is going to wind up being header size and header. We're just going to actually reuse this. All right. We're going to get rid of those guys. And we're going to say if header capacity is equal to 0, then we'll go ahead and bleat there. What did we miss here? Array. Oh, I actually have the same problem up here. That needs an opening parenthesis there. Okay. So we've got that. Our DArray creates is going to be header capacity. Header stride. And then header allocator. Right? All right, this will be header length, header stride. DArray field set length is now just going to be replaced with DArray length set. It's going to take the array and the length. Whoops. So we basically don't need that center property anymore. That's going to be header length. However, though, after we do this DArray create, we actually need to retake the header pointer right here, because the address of that very well could have changed. So we'll take that. That should be good. Okay, let me catch up with chat here. It's been a minute since I've read it. Yes, that makes sense. Stack Overflow seems like a good answer to the question I just made. Yeah. Yeah, and I'm sure Stack Overflow actually talks about Stack Overflows too. But yes. there's that. All right. So D-Ray push shouldn't actually require too much. We're going to use this same logic up here again. Right, so we'll do that. And then we really don't need these things anymore. I don't need capacity either, because now we have the header. So if we do this, we're going to need the header again. So we'll go ahead and get that. The address is going to be equal to header length times header stride. This is going to be header stride. And then the array length set. And get rid of this. Okay. So that's that. This one, I mean, technically we could probably refactor this one, but I think I'm just going to change this for now, for the sake of expediency. So we'll get that one. Pop at is going to be the same thing, darray length set. Go that. Insert at. I think we can go ahead and just leave that the same as well. Darray length set. Oops. Okay. So we have that. The only other thing that we need to do is implement these guys. So I'm just going to copy pasta these. Thorgis56, thank you so much for the Prime. I appreciate it. Thank you very much. All right, let's go ahead and get rid of these KPIs. We also don't need all these. Right. So the only thing that these really have to do is basically update the header. So, in fact, darray length set needs the header. So we can just go in here and grab these, and then set header. Let's see, length set. So we'll just set that to value. Right, so that's that one. Darray stride. Actually, these are just going to be simple getters, so these will be really quick. Right, so return header capacity. And I'm just going to actually slam this in here twice and just change stride and length. Okay, and that should be all the changes we have to do. So this is, I feel like, a much cleaner implementation. Let me just build and make sure I didn't break anything, and then we'll move on to the actual render target. Okay, build clean. Okay. Linker failed. Darray destroy, darray pop at, darray clear. Oh, we probably didn't. Darray pop at, clear, and destroy. Okay. So these ones we need conflicting types. Didn't we have... Oh, that should just be void, not void pointer. Wait a minute. Why though? No, that's not correct. This should be... That should be a void pointer. Okay. What was it again? D-array clear and D-array destroy. Oh, D-array clear, I don't think we actually implemented that. That's gonna go here. All right, so for this one, all we're gonna do for this is... Should I actually bother clearing out the memory? I think I'm just gonna set the length to 0 and call it a day for now. Sleepy Mushroom, thank you for the follow. I greatly appreciate it. And actually, I think you might actually be the 404 follower. I think. Yep, you are. You're follower number 404, which means not found. Which is kind of awesome. But thank you, and I will go ahead and do the hydrate here. So thank you for that. Hello and welcome. Welcome to the stream. Found the error. Oh, Coffee, you did find the error? You got it to render for you? Sure, Sleepy Mushroom, absolutely. Yeah, so what we're working on right now, actually, let me write this one line of code and then I'll explain it. So we want array and 0. So all we're gonna do to clear it is just set the array's length to 0. No, the 404 follower, awesome. Okay. So Sleepy Mushroom, what we're working on is we are building a game engine in C using Vulkan as our rendering backend. And we're building that from scratch. And the idea is that we want to use either no or as few libraries as possible. So right now, the only third-party libraries that we're actually using are the STB image and STB TrueType, which are used for loading various types of image formats and loading fonts. Eventually, we'll probably wind up replacing those things with our own as well, but for the sake of expediency, we wanted to get that in there. But other than that, everything here is built completely from scratch. It is a 3D engine, actually. So let me go ahead and build D-array destroy. Okay. I was going to say let me go ahead and build, but I'm actually in the process of doing a little bit of refactoring here in our array class. I say class loosely. So let me see, destroy. You know what? I am going to break for ads for a second because we like to break on this ad stream when ads come up so that you guys don't miss any explanations. So I'm going to break for ads and then I'll do the full explanation when we come back in like a minute and a half. Just so that you guys don't miss anything. And then, yeah, we're going to go through and show the whole project. We'll kind of step through it real quick. So I will be right back. We are going to break for ads for like a minute and a half, maybe 2-ish. So I'll be right back, and then I'll answer that question, okay? Got about 20 seconds on ads. All right, cool. We are back. So thank you guys for sticking around for that. I did get the build to run, so before I jump into the full explanation, let me show you what we currently have. And we will kind of go from there. So let me see, do I even have my debugger open? I think I do, yes. So right now, I basically, I'm editing in NeoVim, but I do have to debug in VS Code right now, only because I've got some other debuggers that I'm trialing, but I'm not quite comfortable enough with them to use on stream yet. So this is our engine right here, and basically what we have is the ability to have multiple viewports, wireframe view, as well as our sort of world view here. We have a basic terrain system, mesh viewing. We have multi-threaded logic working, so you'll notice that the textures and stuff were kind of working as we were rendering anyways. So we have the ability to do that. We do have a basic Phong lighting model right now. So if I explode this up here. We do have a very basic lighting model in here. And so I have the ability to change the lighting mode so that you can actually see the lighting that's happening. We have fully dynamic lighting, and the ability to visualize normals, things like that. We have the ability to select various objects in the scene. So if I wanted to select the car, I can actually click on that. You'll notice it turns green here. If I wanted to click over here, I can select this guy. We have frustum culling, so you'll notice that as I manipulate the camera here, you know, this object, which has a bunch of stuff inside it, I'll move over here real quick. You know, objects appear and disappear based on my camera angle here, right? So we have that. We basically just recently put in a gizmo for editing. So if I select this car here, I have the ability to move it around in the scene. I have the ability to rotate it on the various axes, scale it, and things of that nature, right? And so everything here has been built completely from scratch, including the math library. Yes, that was a question in here. So for example, we're making our own linear algebra library. Yes, that's also written from scratch. So yeah, we've done quite a lot, right? And it's not, like, visually, it's not really much to look at, right? We are just using a Phong lighting model. There's not really, you know, but it does have, you know, normal maps and things like that, right? So we do have that, but we are going to be switching to PBR at some point as well. We also do have, if I shrink this back, I think you'll be able to see it a little bit easier. We also do have the ability to have UTF-8 text, right? So you can see that I've got some Japanese and Korean text here, as well as like a system text. So we have what we call system text, which is sort of this, we can use a system font file that's installed to render text, or we can use bitmap fonts, which is what this is. So we have that as well. So to give you guys a brief overview of the project, we actually have a website that I've just linked there in chat, which is kohiengine.com, and I'll pull that up here. And this gives a sort of an overview of the entire project, sort of a homepage, if you will. It started off as a tutorial series on YouTube, and it's sort of morphed into a more, I guess, just like a live development thing, where I just kind of live stream the development. So I do most of the development on camera. I guess it's not entirely on camera anymore, because I do some more of the mundane stuff off camera sometimes. But yeah, most of the core components of this were all built on camera, right? Anything that's important, anything that's holds any sort of value whatsoever, is all done on camera. So there's a link here to the YouTube channel. I'll also throw that here in chat that you can go and check out all of the previous content. And then, of course, there's also the GitHub repo where everything is located. This is completely open source. It's Apache 2.0 license, so basically that just means if you use the code, just give me credit. But it's completely open source, so you guys can go in here and grab that. We do have auto-generated API documentation. So we have in here, right now we're only documenting the engine, testbed lib, and Vulkan renderer, which I'll get into in a minute. But you can click into these and let me do containers, for example. And we've got documentation on how to use all these different things, right? So yeah, that was one bit that I did miss. Does it work on Mac OS? Yes, it does. It works on Linux, Windows, and Mac OS. So it has native support for all those things. I will say native with an asterisk on Mac OS because it's utilizing something called Molten VK. Mac OS does not have official Vulkan support, but it has Vulkan support, limited Vulkan support through Molten VK. So at some point, I will be implementing a Metal API layer for Mac OS specifically. But yes, it does actually support all of those platforms, right? So it supports those, and I think I've updated this to say that. Did I? Yeah, Windows, Linux, and Mac OS, right? So the build process is very simple. I did this, I set this up basically to have as few dependencies as possible. So it doesn't require CMake or any of that kind of stuff. Really all you have to have is you have to have the Vulkan SDK installed, and there's no way around that, right? You have to have the Vulkan headers and stuff like that. And then you have to have make installed, and I think that's it. Oh, and Clang. We use Clang to compile for all three platforms. So all you do is run a build script, and boom, it builds, right? That's all there really is to it, right? And so the idea of this is it's supposed to be a educational exercise. And I'm basically kind of going through the process, or a process of creating a game engine. This is not the only way to do it. There are tons of different ways to do it. This is my way of doing it. So it's not saying that, you know, it's better or worse than anything out there. It's just a way of making a game engine from the ground up, right? Have I already implemented another API other than Vulkan? Not yet. But I do have that in the plans. So we are for sure going to have a DirectX API plugin. We're going to have Metal. I haven't decided yet if I'm going to do OpenGL. I might, because it's easy, but it's also deprecated, right? So I don't know if there's much value in doing that, but I may do that. Let me see. So I think that covers the major APIs I'm going to support anyway. We also are implementing a plugin-based architecture. So what we have here is the Vulkan renderer is actually a separate library. That is a renderer plugin to the main engine. So the main engine itself does not actually contain any sort of graphic API logic whatsoever. That is all abstracted to a renderer plugin, and the renderer plugin handles that. So we have a Vulkan renderer plugin. We'll have a DirectX plugin, and then we'll also have, you know, a Metal plugin, things like that. And it's up to the application to choose which one it wants to use and load that up, right? So we're trying to make the engine in such a way where it doesn't sort of enforce these sort of really concrete rules in how you build your application. We're trying to leave a lot of those decisions up to the application. That's actually one of the things we're addressing tonight. We also have this testbed as sort of our application for right now, and then the testbed lib is our game code, which is hot reloadable. So we can compile that and sort of change things on the fly and have that work as well. We're also working on an editor and an editor lib as well. But I had to stop sort of working on that to handle a render graph thing that we're about to actually start building. So I hope I covered everything, at least on a high level, right? There's much more to it than that. The project's been going for a little over 2 years now. So of course, having to do everything on camera does slow things down a bit, but that's kind of where we're at. Let's see. Let me catch up on chat here. So, how did I learn to code? I mean, the short answer is I started coding on and I'm aging myself here by saying this, but I started coding on a MS-DOS 5 machine that had QBasic on it. And I was like 7 at the time, and I just kind of went in there and started reading through the help that was in there and just learning how to program that language. And from there, I just kind of did it as a hobby all the way up through high school when I kind of started getting serious about it. And then at that point, I started learning some other languages. Like I learned C# along the way. I learned Java along the way. And then I took the jump into C++ around 2006 or so, I want to say. And I stuck with C++ from then right up until about 3 years ago when I realized that all the C++ that I was writing was very C-like, and I just decided to use C instead because it's a lot cleaner and simpler. So I hope that answers it. I was curious about DirectX 12 because it's based a lot on C++. So it's actually C. You can use C++ with it, but yeah. But yeah, when we do DirectX 12, that'll be wrapped up in its own sort of library as well. So yeah, the plugin architecture makes it easy to handle platforms. Our platforms technically are the only thing that switches that are actually in the engine itself. So we actually have this platform layer that's in here, and we have this platform interface that we've sort of defined in this platform H that has these sort of platform agnostic functions. And then we have implementations of each one of those here. So we have one for Linux, which is what I'm on right now. We have one for Mac OS and then one for Win32. And then there's some overlap between Linux and Mac OS, so any of those are in this NIX. Any tips when it comes to learning a language? Because I'm at the point where I want to get better so I can code for a project I'm working on. The best thing I would say there, the fastest way to learn any programming language, hands down, no matter what anybody else tells you, the fastest way, hands down, to learn any programming language and get good at it is to use it and to program stuff in that language. Make projects, project after project. Look at examples, like open source examples of projects that are in that language, and look and see what other people do, and just keep writing it, right? Don't be afraid to throw out your code and write it again, right? It's you practicing and writing code is going to be the single fastest way to get better at any language you're working on. You have to get your hands dirty and just do it, right? I've been trying to rewrite what I see on the videos in C++, but sometimes it freaks me out. That C++ it has a bit of a higher barrier to entry than C. A lot, actually, because there's a lot of things that happen right out of the bat that are super complicated if you're new at it, and it's not, and it doesn't really make sense. You don't really know what you're actually doing. So for example, let me go to a implementation file here. I'll go here. And this is a C file, so C++ isn't going to be valid, so this won't compile, but I'll just put it here anyway, right? So one thing that you see a lot of in Hello World examples is you'll see std cout, and then you'll see some string hello world, right? And then you'll see std endline, right? There are so many concepts in that single line of code that are just glossed over. And it's a common thing that you do in C++, like the streaming, which is what this operator is. You're basically streaming this text into the cout stream, right? There's a whole bunch of complexity with C++, right out the gate, that just makes it a much harder language to learn. I always suggest that people start with C and then go to C++. Just because C has a lot of C is a lot simpler to grasp, right? And if you understand C, I think you'll have a better understanding of C++ when you go into it. Yeah, you made the most progress when you broke out of the tutorial loop. Absolutely, yeah. So tutorials only get you so far, right? But like, what really gets you further is breaking out of those and like expanding those tutorials to do your own thing, and then eventually rolling it on your own. Template compiler errors give me a headache. Yeah, I don't use templates. That's for that reason. Well, other reasons than that, but yes. That was one of the things that I specifically didn't use in C++ for sure. I tried to make a string library today, and I felt pain overloading the operators. Yeah, so like C doesn't have operator overloading, right? It doesn't have function overloading, which can be a pain sometimes, but like once you learn to live without it, it's actually, I find, cleaner and easier to work with. You hate namespaces. Yeah, namespaces kind of get in the way. Like the one that everybody makes fun of is std chrono. Like some of the namespaces are just ridiculous. They're like that long across the screen. Can't even forward declare a vector. Yeah, forward declaration gets weird. C++ is way easier than C. It reduces a lot of low-level coding. Class and struct reduce a lot of coding. So, yes and no. But the thing you have to remember is, I mean, yeah, when you have operator overloads and things like that, yeah, absolutely. It reduces the amount of code that you write, but it also hides a lot of complexity and hides a lot of logic. And if you don't know where to look, it may not be obvious as to what's going on. Oh, overhead. Easier is a bit subjective. Does reduce some low level, but I feel like it comes with... So, yeah, I mean, easier is subjective, right? But like, you can't argue against the fact that C is a far simpler language than C++, right? And just due to that alone, like the language complexity of C++, especially modern C++, is insane. It's absolutely insane compared to C. Do you end up writing wrappers around pointers? Absolutely not. I use raw pointers. Many would say smart pointers help to avoid memory leaks. So, here's the thing. If I'm using C or C++, I'm using it because I want to have control over my memory. So why would I then let something control my pointers? Right? Like, to me, if I'm using these languages, it's because I want to control those things. I don't then want to go, I'm going to give those things up and let something else handle it for me. You know? So, I don't know. I mean, maybe it's just the old school way of thinking that I have, but like I find it much more straightforward to keep track of them. But also, I write my own allocators, right? So I don't ever use any sort of smart pointers or anything like that. C does not support overloading. No, it doesn't. I would like to try and do a project in C because I do like the simplicity, but right now I've been getting more and more familiar with C++, but I'm addicted to the simplicity. I would say try both, you know? I will say the first time, like if most of your experience is in C++, the first time you actually sit down to write C, like an entire project in C, there are going to be things that you missed, and there's going to be things that you're used to using that aren't going to be there. But like I said, once you work around those couple things, I don't know. For me, I just prefer it, right? I think it's much, much easier to work with. Function chaining is a way cleaner syntax, in my opinion. It can be. It depends on what you're doing. Chaining is a very good substitute to function overloading. I would agree with that. And I mean, you can function chain and see if you write your stuff to do that. What if you write your own smart pointers? Who's managing who now? Yeah, exactly. So like if I were to do that, then I'd write my own smart pointer, right? But I haven't ever really had a need to. Because the other thing I don't want, especially in high performance applications, is memory fragmentation. Life is so long, you could write your big project in C and then rewrite it again in C++. So don't worry, folks, as long as you have the energy. Yeah, I mean, I suppose that's true to some extent. I've written tons of, private engines in C++. I don't know. Like, there are concepts I've reused from old engines, but it's whatever you prefer to use, right? I prefer C. That's not going to be the right fit for everybody. It's what I prefer, and those are the reasons I prefer it, right? But I'm definitely not going to be like, you shall not ever use C++. That's not how I roll, right? If you want to use C++, go for it. Controlling memory is fun, but maybe that's why I like C, because sometimes you have to manage it. Yeah, well, I mean, I don't know if I would necessarily call it fun. I would call it a necessity, especially when you're working on high-performance applications. Creating a small Grand Theft Auto is a very plausible goal for a single developer. You mean like the 2D version of it? I would agree with you. The 3D version is quite a lot more intense. But like the old school, like Grand Theft Auto, like 1 and 2, yeah, I would agree with that. I've actually had thoughts of making one of those. That might be fun.
Sorry, I don't know that one.
Need to mute my Alexa. Just hears random things sometimes. All right, anyway, we have sort of gotten off track here, so I'm going to get us back on track so that we can start actually looking at our render graph. So since we were able to run the application, we know that our DRA changes are good. So I'm pretty pleased with those. Let me go ahead and let's see. I should have mentioned at the beginning, and I don't think I did. We are on a feature render graph branch that we're going to do all of this work under. So I'm actually going to commit what we have so far, which is just the DRA changes. That way we can actually pick out the render graph stuff a little bit easier. So commits, let's go with DRA refactor to allow frame allocator. Right. Let's go with feature render graph. If I can spell. And so that logic is now available for you guys on the repo in that branch. Okay. Yeah, 3D is a lot more complex. Definitely agree. Yep. Thinking about getting away from the object-oriented program paradigm would be the biggest learning curve for me to do a project in C. Yes. It's what you're used to. It's what a lot of people are used to. I do not use OOP in this code base. There are things that kind of touch on it maybe a little bit, or like are kind of similar to it, but I don't use OOP here. And I won't be using OOP, obviously, because A, we're in C and it doesn't support OOP, but B, because I don't want some sort of hacky version of OOP either. You've already read a bit of the GTA 3 source. Is that available publicly? I wasn't aware that it was. 3D collision detection and physics are a bit harder as the geometry gets a bit more complex, but if one can grab the idea fast, creating our own GTA 3 becomes very doable. So, a 3D physics engine is something I've not attempted before. So I am doing research on it. It might be something that I attempt, maybe. But the thing is, like, those things can get so complex you can spend years writing just one of those by itself. So that may be one of the areas that we eventually wind up using a library. But I think, at least initially, we might do some exploration and writing our own. And we're going to do it using our plugin architecture so we can swap them out, right? So we might use PhysX or Bullet or something like that. I haven't really decided yet, but that's probably one of the areas that we might use a library. All right. I said I was going to circle back to the render graph, and I haven't yet, but let's go ahead and start with that. So I guess let's go ahead and create our render graph folder, or file rather. So I'm going to open engine source renderer, and I'm going to call this rendergraph.h. Whoops, h. And I'll just do the if not def rendergraph h. Define. Oops. Define rendergraph h and f. Right. So there's a couple of pieces of data that we're going to need to know about right off the bat. I can guarantee we're going to need defines for our types, right? We're going to need render types. We're going to need resources, resource types. And we're also going to need frame data, right? And so I guess the first couple of things that we're going to talk about is, like, we have a few different types of things that we're going to create here, right? I guess we can go ahead and say struct, type def, struct render graph, right? We'll call this render graph. And this is going to have a name, right? It's going to take a pointer to the application, which it'll be apparent for that. The reasons for that will be apparent in a bit. We're going to forward declare that so we don't have to include it. Struct application app, I guess we'll call it, right? So that's just a pointer to the application state. And then everything else we're actually going to have to declare before we can actually use it. So this is our render graph. And then we're also going to need to declare a couple of other structures. So we're going to say we need our sources and our sinks, right, that we talked about. So we'll type def a struct render graph source. Oh, we have ads. Got about 25 seconds left on ads. All right, and we're back. Tech Tuner, I don't think I said thank you for the follow. I noticed it was here about 30 minutes ago, so thank you so much for the follow. I appreciate that. All right. So we have our Rendergraph source, and then we're also going to have another one that is going to be Rendergraph sync. Right? Wow, I keep spelling type def wrong tonight for some reason. All right. So we need those types. Camilla VDK, thank you so much for the follow. I appreciate it. Let's see. So I think the first thing that we're going to need is we have to define, I think we'll define our sources and then we'll define what the sinks look like. So a source is going to have an ID, which I'm not 100% sure we're going to use. But we might have, a need for a unique identifier. So I'm going to put it in there for now. Maybe we'll only use it for debugging purposes. I'm not 100% sure yet. We're also going to have a name for it, right? We're going to have, so Rendergraph source is tied to some sort of resource, right? So in this case, we're going to have a texture array, or an array of texture pointers, right? So array of texture pointers, okay? So that's basically what the source provides to us, is some sort of resource, right? In this case, texture pointers. It's an array of texture pointers because if you recall, with Vulkan, we can have multiple frames in flight. And since we're using triple buffering here, we're actually going to wind up having 3 textures for our global depth buffer and color frame buffer, right? And so we're going to have multiples of those, which is why we have more than one pointer to it. You don't know why, but when you try to run the latest branches, you get error opening file in the shaders. You have to run the post build process. So there's depending on whether you're on Linux or Windows, there's a post build sh file or a bat file if you're on Windows. And what that does is it compiles all the shaders to these SPV files. And that's what the engine looks for. So you have to run that first. That's probably what you're running into there. All right, so the other thing that we need is, and I think we need this at least for now, is we need to know what type of source this is, right? So right now we have support for a render target color or a render target or depth stencil, right? And we also need to know the source's origin. So is it global? Does it belong to some other render pass? Or does it belong to this render pass, right? And these are more so just tags that kind of help us identify the resource and where it comes from and where it is within the chain of events, right? So we're gonna type def an enumeration, and we're gonna call this Rendergraph, and we're gonna call this source type. So Rendergraph source type, and we're gonna have Rendergraph source type. Whoops. And the first one is gonna be render target color, and then we'll have Rendergraph source type render target depth stencil, right? Those are the 2 primary resources we're going to be dealing with. So that's, oh my god, I spelled type def wrong again. What is with me today? There we go. Right, so we have the source type, which we'll include here. So we'll say Rendergraph source type. We'll just call that type. And another thing we're going to need is another enumeration. So we'll type def enum rendergraph source origin. And this is basically going to tell us where this comes from. So rendergraph source origin. Excuse me. And this is going to be rendergraph source origin. And we want global, which is the one we're going to use for right now. And then we'll have right. Let's see. We'll go other, right, and self. Right. We need a comma here. All right. So global is basically global to the render graph itself. Other is saying that it's owned by some other render pass, but it's not owned by global or owned globally. And then self means that it belongs to the render pass that is currently hooked to this source. So we will have render graph source origin. Okay. And that's all the data that our render graph source is going to have for now. We may include some other information on that. Maybe, maybe not. I haven't decided yet. But for right now, I think that covers all the bases. A sync is pretty simple. We have a U32 ID, a name, as before. And then we also have a render graph source pointer, which is going to be called our bound source. So this is basically that socket that a source fits into, right? And so this will either be unbound, it'll be a null pointer, or it'll be hooked up to one of these sources. So our syncs will take a source, and the source is ultimately what gives us the reference to our texture or other underlying resource when we actually add those types, okay? So that's our source on our syncs. The last thing that we need to create is an actual render pass, right? So we already have a concept of render pass in the renderer, which is renderer specific. So we need a representation of that within our render graph. And that's going to be a type def struct render graph. And we're just going to call it render graph pass. Oops, pass. Okay. And this is going to include, again, a U32 ID and a name. And then it's also going to include a couple of D arrays. So we're going to have a render graph sources, right? So we're going to have a list of sources for each one. And each pass will also have an array of syncs, right? So we have syncs and sources for each of those things, and those are D arrays. We're also going to have the graphical render pass, right? Because we need to actually control that from our actual pass. So we're going to just call that pass. And then we're going to have a void pointer with some internal data, right? Because every render graph pass is going to have different state information, different data that it's going to have to keep track of and hold on to. And so this internal data is basically going to be a specific type of data for the pass that we're creating. So for example, our skybox render pass is going to have different data that it needs to hold on to than our scene one, right? And so that is what that is for. And then we're going to also have some function pointers that we're going to set up for the individual pieces of this render pass that the render graph looks to. So the first one is going to be return type B8, and we're going to call this an initialize, right? And this one is just going to take struct render graph pass self, right? And so this one is basically just to stand up that internal data as well as anything else it needs, like any shader references, any render passes, all that kind of stuff can get stood up in initialize. The next one is going to also return B8, and that's going to be called execute. So that's going to be when we execute this particular pass. So that's, of course, also going to take Rendergraph pass self. So that's a pointer to the pass itself. We're going to take a struct frame data, and that's going to be called p frame data. That's that frame data object that we sort of pass around everywhere. And then the last one is going to be called destroy, right? And this one, I would almost argue we probably don't need to have as a function pointer. This needs to be void. But we're going to do it for now anyway. And then if we decide that we don't need it, which we might not, we can always remove it later. So basically the idea is we initialize the render graph pass after we've hooked up everything in the render graph. We execute this on the execute call when we actually execute the render graph. When we call the execute frame on the render graph, we will execute that, and then destroy is, I think, pretty self-explanatory. Weird trash can, it worked. Good. Glad to hear it. Camilla, complete beginner here trying to learn programming. Thanks for sharing live content. It's cool to watch the process. Yeah, no problem. No problem at all. I'm glad you're enjoying. And welcome, by the way, first time chat. So welcome to the stream, and thanks again for following. Also, I missed Phoenix Firewings. I think you must have followed me during an ad break, but thank you so much for the follow. I appreciate that. Okay, so we have our Rendergraph pass, and that's most of the data that we're going to need for that. There is one more bit of information that we're going to need, though, which is going to be the individual frame-specific data that we're going to need for the execution of a render pass, right? So this internal data is just some sort of state data that it holds onto, but we're also going to have to feed it like geometry data that it's going to be rendering for every frame and things like that. And that's going to vary from type to type, right? So we're going to have this sort of generic data structure that's going to hold some of the things that all render passes need, and then that'll also have a sort of extended data type of pointer where we can extend that for render passes that need it. So that one, we're going to type def a structure for that as well. And this one we're going to call Rendergraph pass data. Rendergraph pass data. And this is going to include some stuff that you'll recognize probably from our views. So it's going to include a struct viewport pointer. We're just going to call that, VP. It's going to include a mat4 view matrix. It's going to include a mat4, let's see. I don't want it to include math types. Okay. Not sure why it auto imports that sometimes. So mat4, we want projection matrix. And then we also have vec3 view position, which I would argue might not need this. Right? Because we could probably just extract that out of this guy, right? And then the next thing is going to be our void pointer to our ext data, right? And that's going to be the extended data that render passes can use to hold like geometry information, things like that. Psycode, hello. Hey, welcome. Welcome to the stream. How are you doing? All right, so in addition to the sources and sinks and all this other stuff, we actually need this pass data as well. So we're just going to call that pass data, right? And what we're going to basically do is we're going to have jobs that will run that will gather up the pass data for each of these render passes and fill out this object on the pass itself. That way when we call execute, it just pulls what it needs from that, right? So there's that. And then I guess really the only other thing is to finish filling out the render graph itself. So the first thing we're going to have is a D array. And this is going to be of global sources. So if you recall, we had the depth buffer and the color buffer as sort of a global resource that we could pull. And then we also had a global sync, right? So we're going to do rendergraph source. And we're going to call this global sources. Whoops. And then we're going to have another D array. And this one is going to be an array of our passes. So rendergraph pass. And we're going to call this passes. And actually, this is going to be an array of pointers. Pointers to passes. And the reason for this is because the application is actually going to be responsible for creating these passes because the application knows what passes it needs to create. And so the application's actually going to own those passes as well. So the render graph is merely going to take pointers to those passes, and it's not going to own them. And then we're going to have one render graph sync, which is going to be the back. We're going to call it the back buffer global sync, right? And this is basically going to be the final sort of output to all of the passes, right? So everything is eventually going to just feed into this, and that's what's going to be presented to the swap chain eventually, right? Doing great. How about yourself? I'm doing pretty well. Yeah. We're just standing up a render graph. So we're starting that off tonight. I kind of did an explanation of it earlier. And then, yeah, probably we're going to wind up, I'm hoping, finishing it tomorrow. I don't know. We'll see. Ultimately, though, this render graph system is going to be a replacement for our view system. So it should be a lot easier to work with and more flexible. All right, so that's all of our structures. And now I just want to sort of take a second to... no, you're not in the way at all. No, not at all. I'm just coding tonight, right? Like we're just hanging out, keeping it casual. Efiaz? I'm not sure I pronounced that right, but thank you for the follow. Appreciate it. So basically what we're going to do now is basically create the interface to this render graph so that you guys can kind of see how this is going to kind of come together, right? So we're going to export all of these. So we're going to do KAPI B8 render graph create. And so we're going to take in a name. A pointer to the application, and we're going to have a render graph, and we're going to call it out graph, right? So we need a pointer to that, and then obviously the boolean indicates success or failure, right? So that's going to be our create. Obviously we have a create, we need a destroy, so render graph destroy. And this is just, I think, going to take a pointer to the render graph. So we're just going to call that graph. And then we're also going to have a KAPI. And we'll handle the global sources first, right? Because that's the first thing we need to do. So we'll say B8 render graph global source add. And this is going to be taken on the render graph pointer, obviously, because we need to know what graph we're working on. a name for that. We need the source type. So we'll say type, and then source origin, right? And that basically is just to allow us to sort of configure the source that we add, right? So that's that. Now we'll have our pass functions, right? So we'll do KAPI Rendergraph pass create. Obviously, we need the render graph itself, right? We're going to take a name for that. And then we're going to take a couple of function pointers to it, right? Or actually, I think we're just going to take one function pointer to it. We're going to take one function pointer. So that's going to be a B8, and we're going to call this create PFN. And that is going to take struct render pass, render graph pass self, right? Yeah, that makes sense. Okay. And then we're going to do render graph pass out pass, right? So the way that this function is going to work, you know what? Let me kill this other buffer over here. We're not using it. So the way that this is going to work is we're going to take a pointer to the graph, a name for the pass, and then a create function that's going to be used to stand up the other function pointers for that pass. And then we're going to output it to this pass pointer, right? And so the passes as well as the render graph are going to be owned by the application because the application knows what it needs to do to handle those passes, right? Let's see. It's bleating about something, though. This is we're missing a type specifier. Oh, because we didn't actually include it here. Right. Okay. So that's that. Now we need render graph pass. We need something to add our sources and our sinks. So we'll say source add. And this is going to look a lot like this function up here, actually. So what I'm going to do is I'm actually going to copy pasta. So let's see, we have, the only thing we'll have to do is, we'll have constant character pass name, right? And then we'll have source name, right? So this is how it'll know what pass to hook it to, and this is how it'll know what source to hook it to. And then, of course, the type and the origin, right? So that's that. Render graph, pass, sync add, right? And this is going to be render graph, we want the pass name that we're going to add the sync to. Then we want the sync name. I think that's actually all we need. Yeah. So now we can add sources and sinks to our passes. And then the last thing that we're going to need is we're going to need something to sort of actually do all the linking up of resources and pointer forwarding and all that stuff. So we're actually going to need render graph pass, and then we're going to say set sync linkage, right? And this is how we're gonna wind up linking it. So we're gonna say Rendergraph graph, and then we're gonna say node name, and then sync name, and then we're also going to provide the source node name and the source name, right? And so basically we're going to be able to configure and like hook all this stuff up by name. So we're going to say when we set this should be pass sync, or pass rather, pass. I don't know why I said node, it should be pass. Sorry about that. All right, so what we're going to do is we're going to say for this pass on this sync, we are going to take this source from this pass and link it, right? So that's essentially what that's going to do, and that's essentially going to resolve pointers internally so that we can actually bind our resources later on and actually use them. Finally, we're going to have a method that we're going to call finalize. So we'll say Rendergraph finalize, Rendergraph, and that's all it's going to take. And basically what that's going to do is it's going to, after we've linked all this stuff, it's going to go in and verify that all the resources are hooked correctly from top to bottom, and make sure that everything is resolved internally and get it ready for use. And then finally, the last bit that we have, the last function that we have is Rendergraph execute, right? And this is what is actually going to execute a frame. Actually, I'm going to call this execute frame. And we have Rendergraph graph, and then we have frame data, p frame data, right? And that's just going to provide any frame specific data that we need, as well as our allocator and all that other stuff. So this is our interface for our render graph, right? And we have ads, so I'm going to break for a second, and then we're going to tie up for the night. Is the thing that shows the file name at the top of NeoVim plugin? No, it's just a configuration option. I mean, there are plugins that like power the icons and stuff, but so while the ads are running, I'm just going to go ahead and get this committed. We got about 20 seconds on ads. All right. So I've gone ahead and committed this and pushed it up to the branch on the repo so that you guys can access this if you want. But this is our interface. So basically the way that this is going to work in terms of logic is we'll create the render pass. We will add our global sources, so that would be our color buffer as well as our depth buffer. Then we will create each of our render passes. For each of those render passes, we will add sources and sinks, and then set sink leakage for each one of those. Once we've done that for all the render passes, then we will finalize that render pass. And then for each frame, when we go to render, we will call Rendergraph execute frame, and it will go through and execute the passes in the order that they were added. And it's only going to add them, or it's only going to execute them in the order that they added as a temporary measure until we actually have some advanced dependency resolving and stuff like that to figure it out automatically. So that's sort of a phase 2. But yeah, that's basically where we're going to wind up. And yeah, I think that's probably going to do it for tonight. So I am going to be picking this back up tomorrow night. So it'll be tomorrow night, 9 p.m. Eastern Daylight Time. Yeah. So we'll be back tomorrow to pick up work on this, where we'll actually implement these things, get our passes set up, hopefully get all of our passes set up, and maybe start working on splitting apart our views and deprecating that system, right? And then once we have that set up, and once all of this is tied in, then we can also go implement the same thing for the editor application, which will really just be copying over the views, or I should say the passes now, and using those in the same way that we're using it in the testbed application. So with all that said, that is going to do it for tonight. Let me see who is online that I can raid. Let's see. You know what? I am going to go with... I'm going to go with Ferret Software tonight. I haven't rated them in a little bit, so I'm going to raid them tonight. Ferret Software is a channel owned by Pirate Software, who's a fellow game developer here on Twitch. And he basically has started essentially a rescue for ferrets. And all of the ad revenue from this channel goes to taking care of those ferrets. So it handles their medical bills, their food, all the supplies they need, all that stuff. And he's basically taken in, I think he has like 16 of them now. He's taken them in from bad situations or people that could no longer take care of them. Some of them were used for medical testing. So he's taken them in from a lot of different bad situations, and is giving them a good home with good food and good nutrition and good well balanced diet and things like that, and good medical care. And I think it's a really good cause. And so that's what we're going to go ahead and do. We're going to raid them. And I suggest that you guys follow them because, it's really adorable to watch them run around. They're probably all sleeping now, but when they're playing, it's hilarious to watch them interact with one another. It's really great. So anyway, thank you guys so much for being here. I really appreciate it. If you haven't already, go ahead and follow me so that you get the update or the notification for when we go live tomorrow. And I will see you guys next time. Oops. Canceled the raid for some reason. Not sure why it did that. Maybe it timed out. Alright. See you guys later.